Hello everyone, welcome to my YouTube channel Civil Sphere Insights. In this video, I will be dealing with some important MCQ of RCC for upcoming Apsc, Jlee and JLEE exams for civil engineering. So let us start. So the first question is, minimum grade of concrete to be used in RCC as per IS 456-2000 is, so minimum grade of concrete as per IS 456 to be used in RCC work, that is M20, right? But in earlier IS code, which was IS 456 1978 মতে minimum কিমান আছিলে M20 আছিলে. So now recent edition কি কৰা হৈছে M20 লকে nominal grade of concrete use কৰিব পাৰি, right? Now so M20 mixer যদি আমি proportion খিনি চাও, so 1:1.5:3, right? So here 1 part of cement, 1.5 part of sand and 3 part of coarse aggregate, right? Okay, now let's move to the next question. So the second question is, steel is preferred as reinforced material in concrete because option A, it is easily available, it is the cheapest and good strength, it forms a good bond, the coefficient of thermal expansion of steel and concrete is almost same. So see, steel আমি reinforcement হিসাবে use কৰো, right? In earlier times bamboo was used as reinforcement, but steel is found to be the most suitable reinforcing material because it has some quality. First of all is steel or concrete or thermal expansion, coefficient of thermal expansion same, price same হয়. concrete কাৰণে কিমান 11 into 10 raised to the power minus 6 upon per degree Celsius, আৰু concrete steel কাৰণে 12 into 10 raised to the power minus 6 per degree Celsius. So see, this is nearly equal, nearly same. So and also steel কি থাকে per unit length of strength বেশি পাও as compared to other material. per unit length যদি compare করো তাহলে steel or strength বেশি পাম. Secondly, thirdly, steel আমি কি কৰিব পাৰো, সহজে আমি কাটিং কৰিব পাৰো, right? কাটিং কৰিব পাৰো, welding কৰিব পাৰো. So welding কৰিব পাৰো, lifting কৰিব পাৰো. So these are the reasons why we use steel as reinforcing material nowadays. Okay, now let's see the next question. So the modulus of elasticity of concrete can be assumed as, so modulus of elasticity is denoted by E, right, of concrete. So modulus of elasticity of concrete is 5000 Apsc as per IS 456-2000, but according to earlier IS 456 1978 মধ্যে 5700 was there. So ৰাখিবা, as per IS 456 এর মধ্যে 5000 into under root of Apsc. Here Apsc is the characteristic strength. Okay, so let's move to the next question. Modular ratio in reinforced concrete is defined as, so modular ratio hol M, right? Modular ratio of concrete is defined as modulus of elasticity of steel upon modulus of elasticity of concrete, modulus of elasticity of concrete upon modulus of elasticity of steel, coefficient of linear expansion of steel, none of the above. Now modulus of elasticity of steel upon modulus of elasticity of concrete, it will be the right answer. So here modulus of elasticity of steel upon modulus of elasticity of concrete. Okay, important question. The first 5 number question is flexural strength of concrete FCR is 0.7 of FCK, under root of FCK, here under root of FCK, and 0.3 of under root of FCK. Right? Flexural strength is also called as a tensile strength. Okay, tensile strength of concrete. So we know that tensile strength of concrete is very less, which is 0.7 under root of FCK. Remember, 0.7 under root of FCK. Okay. Now the next question is, as per IS 456-2000, maximum cement content in RCC shall be. So IS 456-2000 মতে maximum cement content RCC কিমান হ'ব লাগে? Maximum cement content to হ'ব আমাৰ 450 kg. Okay, 450 kg. Option the unit is wrong, actually meant typing error. 450 kg for maximum cement, right? Minimum যদি ক'ব যাওঁ, minimum cement content in RCC will be 300 kg. Okay, as per IS 456. Okay, as per IS 456, maximum water cement ratio 0.5. Okay, this all as per IS 456. Okay, now let's see the next question. The unit weight of reinforced cement concrete according to IS 875 1987. So IS 875 1987 মতে RCC unit weight কিমান? So RCC unit weight আমি জানো যে RCC unit weight কিমান হয়? 25 kg per meter cube, right? PCC और concrete to কাৰণে কিমান হয়? PCC और concrete to কাৰণে 24 kg upon meter cube, right? আৰু কি আছিলে সিমেন্টৰ কাৰণে কিমান হয়? 1400 kg per meter cube, right? And steelৰ কাৰণে কিমান হয়? Steelৰ কাৰণে 7850 kg per meter cube, right? So this thing you should remember. Okay, you should remember this. These are important sometimes. Okay, these things are important. Remember this data. So now the next question is, according to IS 456-2000, what should be the nominal cover to reinforcement for footings? So footing or কাৰণে nominal cover কিমান হ'ব লাগে? That is 50 mm, right? 50 mm. অর্থাৎ কিবা nominal cover for footing is 50 mm. আৰু কেইটামান আছে, which are important. So footing or কাৰণে কিমান? Nominal cover কিমান? Nominal cover footing or কাৰণে কিমান? 50 mm. This is minimum. Okay, now see beam or কাৰণে কিমান লাগে? For beams minimum nominal cover is 25 mm. Okay, slab or কাৰণে কিমান লাগে? Slab or কাৰণে 20 mm. কুলমৰ কাৰণে 40 mm. Okay, very important. For what condition? Mild exposure condition. Okay, for mild exposure condition, remember. Next question is, for an I section the maximum bending stress occurs at. So let us do I section. Bending it will bend like this way, right? If some load acting on this like this is a load, so it will bend like this. So here will be stress, right? So stress will be induced like this. So stress diagram will be like this. So the maximum stress is out of favor. Okay, this is the maximum stress. Okay, if this question is asked for shear stress, then the diagram will be like this. Then the maximum shear stress will be at the neutral axis. Okay, this is the neutral axis, right? So here will be the maximum shear stress, but for bending stress, the maximum bending stress will be at outer fiber of the beam. Okay, now the extreme the answer is the extreme outermost fiber. Okay, okay, the next question is the ultimate limit state of bending failure deemed to have reached in an RC beam when the strain in concrete at the extreme compression fiber reaches a value of. So question to সুধিছে যে আমাৰ কনক্ৰিটৰ এক্সট্ৰিম কম্প্ৰেছন ফাইবাৰত কিমান ষ্ট্ৰেন আহিলে RCC বিমটোৱে ফেইলাৰ কৰে. So if I draw stress and strain diagram of this, let us insert some rod here. Okay, reinforcement bar, these are reinforcement bar. Here the depth is D and this is the capital D, which is effective depth, right? Here we assume a neutral axis. Okay, that is neutral axis. Let us draw strain diagram. So it will be strain, right? So this is the compression. This is compression and this is tension, right? So the outermost compression fiber will have 0.0035. 0.0035. This is the maximum strain. Above this, the beam will be failure, right? Above this beam will be failed. We assume while designing that a beam reaches to a maximum value of strain 0.0035, and there is a strain value 0.002. Okay, and for steel it will, the maximum strain value for steel is 0.002.87 Fy upon elastic modulus of steel. Okay, now see stress diagram. So here tension force will be there, 0.87 Fy, 0.87 Fy AST. Okay, this is the neutral axis depth, right? And from top to bottom this is XU limiting. It is called critical neutral axis depth. Okay, and from here to here, from top to this fiber, the distance is 0.42 XU. Okay, Now see, now in the compression zone, the stress diagram will be like this. Up to this 0.0022, the stress of the block will be parabolic. Then from 0.0022 to 0.0035, the stress block will have rectangular. The stress block will have rectangular diagram. Okay. So here both compression and resultant of compression and tension force will be occurring, which is 0.36 Apsc Bxu. Okay, and the distance from outer compression fiber to this combined stress is 0.42 Xu. Okay, now from tension force to this compression force, the distance between compression force and tension force is called lever arm, right? Okay, now the question is আমাৰ compression outermost compression fiber maximum কিমান strain আহে যেতিয়া beamte fail কৰিব, that is 0.0035, right? In limit state method, what is the minimum percentage of steel required? There is a formula for minimum percentage of steel, that is AST upon BD equal 0.85 upon FY, right? So here percentage is so multiply by 100 D, so it will be 85 upon FY, right? The answer is 85 upon FY. So according to IS 456-2000, shear reinforcement is dependent on. So question hodise je according to IS 456 shear reinforcement কোনটো factor upon depend করে. So আমি জানো যে shear reinforcement percentage of reinforcement upon depend কৰিবই, tension obviously depend কৰিব, আৰু আমি যেতিয়া shear reinforcement ওলাও তেতিয়া tension reinforcement ওলাও, right? Tension reinforcement and grade of concrete, right? So this will depend on both A and B. So the question is, in RCC beam, the side face reinforcement provided if depth of wave exceeds. So depth of wave kiman exceed korile ami side face reinforcement provide koru beamot. So ami janu je jodi beam to torsion acting kori thake, jodi torsion act kori thake teta hole jodi wave or depth 450 mm के बेसी হয়, beamor wave or depth যদি 450 mm के যদি বেশি হয় তাহলে side face reinforcement provide করু, right? But if no torsion is acting on the beam, then 750 mm के যদি বেশি হয় wave তেতিয়া আমি কি করু side face reinforcement provide করু, মনত রাখিবা। আৰু এটা কথা, side face reinforcement যে provide করু তারে amount to হল 0.1% of BD, মানে maximum cross sectional area 0.1% side face reinforcement provide করু, এতকে বেশি হব না লাগে। Okay, now the next question is, as per IS 456, the maximum area of tension reinforcement in a beam shall not exceed where B is the breadth of the beam, D is the overall depth of the beam. Okay, so আমি যেতিয়া beam design কৰো, beam design কৰোতে এটা বস্তু চেক কৰিব লাগে, সেইটো হল reinforcement to আমাৰ যেটো maximum criteria দিয়া আছে as per IS 456-2000 মতে, সেই criteria to exceed কৰিছে নেকি, সেইটো হল আমাৰ 0.04 dB, that is যেটা আমি beam design কৰো maximum reinforcement that can be provided is 4% of area, right? 4% of cross section area. So cross section area 4%, আমি reinforcement provide কৰো, right? Okay, the next question is, a simply supported beam has an effective span of 16 meter. What should be the limiting ratio of span to effective depth as per IS 456 2000? So এনেকুৱা ধৰণৰ question সদায় আহি থকা দেখা পাওঁ আমি এক্সামত, so প্ৰায় আহি থাকে এনেকুৱা ধৰণৰ question. So এইটো হ'ল আমাৰ IS কোডত কিছুমান ভ্যালু দিয়া আছে ধৰা বিমৰ কাৰণে, so বিমৰ কাৰণে কি দিয়া আছে, span to effective depth L/D ratio দিয়া আছে, right? So simply supported কাৰণে, simply supported beamৰ কাৰণে L/D, that is minimum. Okay, this is minimum. L/D ratio you have to give minimum 20. Okay, minimum 20. And continuous beamৰ কাৰণে কিমান আছে, 26. Okay, and cantilever beamৰ কাৰণে 7. These are up to span 10 meter. Up to 10 meter span, this criteria is valid. If the span is exceeds 10 meter, then we'll have to multiply 10 upon span. So in the question, in simplest we have effective span kiman ase 16 meter. So 16 meter is obviously 10 ke beshi. So ami ki koribo lagibo, 10 upon, so simply supported beam karone kiman 20, right? Aru ki dia ase 20 ক multiply koribole ki dia multiply korim 10 upon span kiman ase 16 meter. So 10, this is 8, right? So 100 upon 8, so that will be 12.5, right? This is 12.5. Okay, now the next question is, doubly reinforced beam is recommended when? So doubly reinforcement beam kita use koro ami, doubly reinforcement beam beamot ki kora hoy compression and this is tension, right? Simply supported beam, for simply supported beam this is tension and this is compression. So we provide reinforcement both in tension and compression zone. So this is called doubly reinforcement. So doubly reinforced beamot kita recommend koro ami jeti amar moment of resistance required is greater than moment of resistance design. যেটা আমি ডিজাইন কৰিছো, ডিজাইন কৰাৰ মতে যিমান moment of resistance পাইছো তাতকে যদি বেছি হয়, আমাৰ ৰিকোয়ার্ডটো যদি বেছি হৈ যায়, তেতিয়াহ'লে কি কৰোঁ আমি বিমটো ৰিডিজাইন কৰোঁ, ৰাইট? এজ এ ডাবলি ৰেইনফৰ্চমেণ্ট হিচাপে ডিজাইন কৰোঁ, ৰিডিজাইন কৰোঁ. এতিয়া কুৱেশ্যনত কি সুধিছে যে ডাবলি ৰেইনফৰ্চমেণ্ট বিম আমি কেতিয়া ৰিকমেণ্ড কৰোঁ? when depth of beam is restricted, when breadth of the beam is restricted, both breadth and depth are restricted, shear is high. So doubly reinforcement beam kita recommend koro jetia moment of resistance is greater than moment of resistance required is greater than moment of resistance provided, right? So and also when the cross section area of the beam is given, which when it is restricted, and then we will design as reinforcement beam, doubly reinforcement. Okay, so the option will be C. Okay, so both breadth and depth are restricted, right? When the cross section area is restricted, then we will design the beam as doubly reinforcement, right? So let's see the next question. So a simply supported beam is having a clear span of 4 meter, support width is 400 meter, overall depth of the beam is 450 mm and effective cover is 50 mm. The effective span of the beam as in the limit state method will be, see this question is taken from limit state designer pra jeta ami jeta beam design koru, beam designer first step ote ki koru ami effective span ulao, right? So how will you proceed this question? we have two condition for finding L effective, right? L effective কাৰণে কি লাগে আমাক minimum of কি আছে the formula আছে minimum of L clear plus D and B upon 2 plus B plus LC, right? So this is the criteria. So আমি এতিয়া কি কৰিম আমি ভ্যালু এটা পুট কৰিম এতে কি আছে simply about is having a clear span of 4 meter. So এতে যদি 4 meter plus D ভ্যালু কিমান দিয়া আছে overall depth of the beam is 450 mm, right? So 450 mm and next condition কি আছে width কিমান দিয়া আছে 400 plus LC কিমান আছে 4 meter, right? So this is in mm, right? So 4.45 meter and the next one is 4.4 meter. So which is greater? This one is greater, so this is cancelled and this is to be accepted. So 4.4 is the correct answer. So the option A will be right answer, right? Okay, so now let's see the next question. The maximum and maximum, it will be minimum. Okay, so maximum and minimum, this will be minimum. The maximum and minimum value of cross sectional area of longitudinal reinforcement for coulomb are. So আমি coulomb design কৰোঁতে কি কৰোঁ maximum and minimum reinforcement to কি কৰোঁ আমি cross check কৰোঁ, right? So hey maximum and minimum value to দিছে তো maximum আমি কিমান দিব পাৰোঁ coulomb design that is 0.8% আৰু maximum কিমান দিব আমি 0.8% and maximum, so it will be minimum. Okay, this will be minimum. So minimum, first one is minimum, okay, and then second one is maximum. Okay, the minimum and maximum, minimum to whole 0.8% and maximum to whole amount 6%. Okay, this is the correct answer, remember. The next question is the minimum number of main steel were provided in a circular RCC coulomb, or that is for rectangular bar we have to give minimum 4 RCC bar, right? And for circular beam we have to give we have to provide it minimum 6 bar. Okay, minimum 6 bar for circular coulomb. For rectangular coulomb we have to provide 4. So the answer is 6. So the next question is in a RCC footing on soil the minimum thickness at A should not be less than. Question to ki hoise, let us do a diagram. Okay, consider this as a footing. Here are soil. Okay, this footing is resting on soil and this footing is resting on pile. Okay, so in the question it is asking this value, minimum this. Okay, the value of this this thickness, it is called edge thickness. So minimum edge thickness for footing which is resting on soil is 150 mm. Okay, that is 150 mm when the footing is resting on the soil. But if it is resting on the pile, then the value will be different. That is 300. That is 300 mm. Okay, the next question is as per Indian Standard Code for practice for pre-stressed concrete IS 1343/1980, the minimum grade of concrete to be used for post-tension and pre-tension structural elements are respectively. So post-tension এর কারণে আমি কি মান ইউজ করব 30 and pre-tension এর কারণে 40. Okay, so 30 and 40. For post-tension 30 and for pre-tension 50. Okay, so thank you. Please comment down below if you have any doubt, and if you have any recommendation, please comment down below, and subscribe and share the video. Thank you.